portfolio manager in Network Rail. I work in the track department. I look after development of the track projects. So generally, I look after what we call now the Pace 1 phase. Used to be Grit 1 to 3. Hasn't been Grit for a long time, but people still use the terminology. So we try to tie down the access, the resources, and tie it all together. So we've got a baseline plan ready to deliver. So that's generally what I do. So I'm not actually at the delivery end of things anymore. So if there's any minute detail on how it was delivered and all that stuff within what I'm about to show, you'll have to forgive me, I may not know the detail. But yeah, if we can go to the next slide, please. Right, just a quick outline of the agenda. So I've just done the introduction, some interesting facts about the tunnel, just because I find them interesting. Sudbrook, we can't really talk about the tunnel without talking about the pumping station that goes along with it. I'll go into previous renewals, how we used to do it, additional measures we need to put in place as a track renewals department to work in the Severn Tunnel, the access points we use. There's videos in here. Apologies to people online. Hopefully it works okay and doesn't buffer too much, but obviously doing videos online and AIVR and stuff we use a lot. Trying to do that on Teams doesn't work very well, but I thought it was a good addition to the presentation. I'll talk about W1012 project. So I worked on that for a bit in CP6. I didn't actually get any funding. We couldn't sort of progress to pace 3 and actually implement anything on that. But I'll talk about what we did anyway and what we might do in the future. More recent renewals. So we've kind of changed the access strategy about how we do it to make it more efficient. And it's led us towards our last mobilisation, which should be the last one for circa 15 years, hopefully, and go through the benefits of that. I'll go through the CP7 access plans that we've got for the rest of the future control period, and then any other future plans that I may or may not be able to talk about. Okay, we go to the next slide, please. If there's any questions as we go through, just shout rather than save them to the end. It's up to you. I don't mind. I've tried to make it all sense chronological order, but I may not have done, so I don't mind jumping about. So interesting facts. I used a well-known search engine to find these. There are others available, but the tunnel itself was constructed between 1873 and 1886. So it took just under 14 years from when they started to when the first service was run through it. Some delays were because I think a year or so in, 6 years, sorry, it didn't seem that long in, but they hit what they called the Great Spring, and that's why we have the Sudbrook pumping station to pump all that water out of the tunnel. That pumping station moves 50 million litres of water a day out of the tunnel. The tunnel is 7,008 metres long, 4.5 miles, just under. Only 3,600 metres of it are under the river. It was the longest underwater tunnel in the world until 1987. The longest tunnel in the UK for more than 100 years. Channel Tunnel surpassed it in 2007. 200 trains per day go through that. It's 2012. We've obviously had a lot of timetable changes since that. So that may have gone up, but if you look at the next point, it's controlled as single signalling section, so it actually restricts the services you can run through there. So we may not have gotten much more than that under those restrictions. There's 1 in 90, 1 in 100 gradients into and out of the tunnel. So there's a picture here, just shows you where the Severn Tunnel is. You can't see it very well in relation to the original Severn Road Bridge and second Severn Crossing. I was in a meeting recently and someone said, why wasn't it built as a bridge? And I don't know the answer to that. And I actually tried to look it up yesterday, and I understand there was actually a rail Severn bridge in the late 1800s.
Yeah, that was.
Yeah, but it fell down because boats kept crashing into it. So I couldn't find out if there's any business case done as to whether they decided to build a tunnel versus a bridge. But someone asked me, not me, but it came from a meeting. I thought it was relevant to talk about it. There's a few other things I picked up. I ran out of room on the presentation. It's over 76 million bricks were used in the construction of the tunnel. And the lining is 26 to 30 inches thick as they go through. So next slide, please. So in terms of drainage in the tunnel, it's obviously a big restriction for us renewing the track. I've got access to Network Rail's tunnel management strategy portal, and I found this diagram on there. this is the track tunnel. I don't know what this is. So, but I thought it was good just to show it because you can see the culvert in the 6 foot. It's at track level, you just see catch pits, look like normal catch pits, but it comes down and it barrels out at the bottom. So it's an issue for us until I'll come to that on another slide. But in terms of where we put the track, the loading from the sleepers, we try and stay away from the inside rail being on top of that barrel. So as I said, a continuous 6 foot culvert through the tunnel. It leads down to the lowest point of the tunnel where the water is pumped back to the surface and back into the river. Whenever we're transporting hazardous services or services carrying hazardous material, there's no passenger service allowed in the tunnel at the same time. I didn't know that, for fear of contamination, fire, etc. Sudbrook does actually provide a pedestrian access to the lowest point of the tunnel, which I think is this. It's not used very often. We certainly don't use it, but it is there as an option. Ventilation is pumped in through this system as well. I also found out that previously, when they first built it and put it into service, the ventilation was extracted out and not in, and the fans kept getting clogged up with steam dust and stuff. So they actually reversed it and they pumped the air in now instead of out. And anecdotally, the whole tunnel would flood in 26 minutes if the pumps were turned off. So yeah, pretty scary amounts of water in there. Can you go to the next slide, please? So previous renewals. So this is how we used to do it. It's a very aggressive environment in the tunnel. I don't know how many people have been in there before, but it's as Gary and I were discussing before, and it's a pretty unique environment. This picture shows the old track. So this is the down main, I'm pretty sure. We're going to renew June this year. And this picture was taken in the 10-day block in 2023. So that's the line, that's the up main that we were renewing at the time. So you can see the difference in the ballast, the rail, sleepers, still fast clip sleepers, pretty modern, but they're all got the rail corroded and base plates corroded. As I said, it's a pretty harsh environment for the system to operate. We generally renew the whole system, which is the track, the ballast, and the sleepers, every 15 years. The rail is done cyclically on about every 5 years. We previously used to work around undertaking half a mile a weekend, 880 yards. We generally get 6 of those a year. It would be strategic areas really rather than a start to finish exercise, but we do as much as we can in there each year. It was certainly inefficient in terms of cost and outputs, and a risky strategy in terms of handbacks to Monday morning, but that was the way we used to work in terms of 27 hours, 50-hour possession. So I know we can say that is risky now, but it's how we always used to work. So that was how we used to do it. Go on to the next slide, please. So it's just a few additional measures we have to put in place from a normal track renewal working in the Severn Tunnel. So we have to use smaller plants. So the road rail vehicles we use, they are smaller because the tail swing can potentially make contact with the tunnel lining. For some activities where we're using lots of diesel-based machinery in a small area, we have to wear respiratory equipment, which is air-fed masks, and so they're fully safe from the fumes. But we do monitor it throughout. There's a personal evacuation plan. So you'll see on one of the videos, people are wearing tags and stuff. So when they sign into site, everyone knows where everyone is. And whenever you enter the tunnel, they know how many people are in there. So if we do have an incident, we know how many people need to escape. As you can imagine, there's no phone signal in there. So radio comms only using GSMR inside the tunnel. And something I sort of thought, we don't do tunnel monitoring this tunnel. It's a continuous structure, it's self-supporting. So us taking the ballast out doesn't affect the structural stability of the structure, but some tunnels we do have to with track renewals where the ballast forms a structural part of the tunnel. Okay, next slide, please. So the access points. So we've got one each end, obviously. The previous renewals I touched upon. So we undertook a 10-day block in 23-24 and a 10-day block in 22-23. One of them, we went from the middle of the tunnel back towards the Welsh portal, and the other one went from the middle of the tunnel to the English portal. Undertaking the Welsh End work, and obviously when we come to the future, we're going to do the whole line, we use both. But this is Severn Tunnel Junction Yard here. This isn't big enough for our site setup, so we generally use this area of land as well. It's not Network Rail owned, but we never have any issue with using it. I dread to think what we do if the owner sold it, but it's still there at the moment, so we use that every year. Probably quite good investment actually. If don't know what they paid for it way back when, but probably worth investing in, knowing the railway will turn up every year. But it is 1,400 meters from the western portal, so an access point that far away is just added to the risk and the low output rates we get within the tunnel. And at the other end, we generally use Pilning Station. There's other wraps a bit further up, but there's very, very small, very tight space. And this is 1,800 meters from the eastern portal. So again, doesn't help outputs when we're in the tunnel. Next slide, please. And this is a little 2-minute video that was sent out during the 23-24 block. So people in the room, I'm sure it worked fine, but apologies if anyone online, it buffers too much, but we can just play the video. Thank you. So that was Brian Painter, the track director, although currently seconded out on to do another little project. You'll notice in the video, Brian wasn't prepared for how many weekends it would have taken to do that work. I have actually done that in another slide, so I can go through that in terms of benefits assessment for the strategy we've got for access. You'll also notice the machine putting a single sleeper in the video. So that's us putting short-ended sleepers in around the catch bits. So I'd say that the confines of the tunnel really constrain what we can do. So I'll just quickly go through W10, W12. We were omitted to undertake some investigations in CP6. Unfortunately, the funding required for the implementation of it, the business case wasn't prioritised over other enhancements at the time. So the best way to deliver any enhancement is alongside renewals. We've missed the opportunity to do this work alongside these Severn Tunnel track renewals, unfortunately. So if this project were to get resurrected in CP7, CP8, we'd have to probably take the whole track system out. But if you're looking at CP8, you might as well wait CP9, then you'd be renewing it again anyway. But so this is just an extract of a spreadsheet I've kept. This is looking at and it's almost a gigabyte in size. This is a spreadsheet looking at all of the points of the tunnel we need to intervene on to get it clear to W12. And as we had a point cloud survey of the entire tunnel, which actually was quite lucky for the renewals we did, because I don't think we'd have surveyed it starting from scratch and be ready for the possession otherwise. So these are the point cloud extracts. There's pictures of the infringements there. You'll see here some of the options for the interventions was something like remove 1 leaf of brickwork, which we're obviously not going to do. So there's proposals here, but we'd have had to look into it a bit further, because that's not something we want to start doing. But the gauging analysis here just shows we've got the track position here. We have to avoid the drainage in the middle. As I said, the barrel arch comes out, so we can't go too far towards the 6 foot. We've got the lining of the tunnel to avoid in the cess, and we've obviously got to stay in line with the OLE above us. So it's a very, very tight needle to thread, effectively. Thank you. Next slide. So away from the 50-hour weekends that we traditionally do. So as I said, 22, 23, 23, 24, we've undertaken 2 10-day blockades to do half of the tunnel each. We've seen a preference in access from the operators change post-COVID. So actually the leisure market generates more revenue for them now rather than commuters. So they'd actually like us to avoid weekends, which is traditionally when we would work. That's led us to midweek blockade opportunities that we previously probably wouldn't have been able to have. For us, it's more efficient delivery. It's less risk, as I mentioned. If you do it 6 times, you've got 6 risks of overrun for Monday morning and disrupting the passengers, or unplanned disruption at least. And ultimately, for the operators, it's less weekends that are disrupted. Ultimately, we do it quicker, so it's a reduction in Schedule 4 overall for the business. And then the 2 sites, I've done this in the wrong order, strangely, but we did just over 4,000 yards in 22-23. It was 33 engineering trains over 7 stages. So SEO, route services, the team in NetRail that supplies with the engineering trains, they don't have enough wagons for us to rip the whole tunnel out, or the whole half of the tunnel in this case. And replace all the ballast, take all the ballast away and put it all back. So there's also a benefit in terms of risk management. If something were to go pop, something catastrophic in the middle of the tunnel, we've only ripped out and only have to replace circa 800 yards of track to get it back open to passengers. So we have to do it in stages. The scrap train stays on site, takes scrap up to a field in Caldecott, which is what this picture is of. And you can see here 3 timber sleepers that were clearly around a catch pit previously. That goes up, that gets unloaded while the ballast and spoil trains go round up to Gloucester, back down to Westbury, replenished or unloaded and back to site for us to do it again. So we had 36 200-metre rails, 6,500 EG47 sleepers, and 16,000 tonnes of ballast in 22-23. We use EG47 sleepers because they're 50 mil, I think, someone's going to correct on that. 50 mil shallower than G44, so it gives us extra room for the OLE system. And then we did the other half of the tunnel, which is 3,600 yards of the up main in 23-24. That was 30 engineering trains, over 6 stages, 31 rails, 5,000 sleepers, and 11,600 tonnes of ballast. Next slide, please. Sorry, it's another video, but it goes on to, it's the same people. There's a slight overlap, but it's more focused on the operators and working with the operators to get to the strategy we're going to employ in 24-25. So worth playing, I thought. There's the three things just want to mention on that. So RRS is rail replacement services. He didn't outline that. So that's buses to move people around. Sean Hodges there, the Colas rail chap, said he'd undertake this work in a quarter of the time. That's not quite true, not even close actually. So I'll go through that, but I just thought I'd mention that. And there was something else which I'd forgotten. So oh yeah, so CP7 Year 1, we originally had this again as 2 10-day blocks, but Brian challenged us and went to GWR and said, can we do it in one hit in 16 days? So that's what we're planning to do. We've got a 16-day block agreed in 24-25, June this year, I think, roughly, to complete the entire down main. So the line on the left here, you can see in this picture, this is the up main we renewed this year, this financial year, not this calendar year. This plan is 49 engineering trains over 11 stages, 67 rails, 11,000 sleepers, and 26,000 tons of ballast. So this we've taken the learning from the 10-day block, applied it to this. It does give us some additional problems. The main one of which, there were some issues with getting the rail on the ground, but we've gotten over that. That's sorted. The additional problem here, actually, that we're still working through is sleeper loading. So 11,000 sleepers is more than they can load at Doncaster and bring down on salmon. They haven't got enough salmons, they can't get enough sleepers. So what we've planned to do is we plan to have an off-site loading facility at Taunton to load the sleepers on the region and take them up to the tunnel. There's that one, and I think, and again, I think we're over this, but that amount of ballast is too much for Westbury to handle in one go as well. I think the maximum capacity is 14,000 tons. So relating that back to the Newnham talk you had a couple of weeks ago, when Newnham was shut, that is the path for bulk ballast to Westbury. We had to cancel 3 or 4 renewals during that time because Westbury didn't have enough ballast to service the work we were planning at the time. So replenishing Westbury to keep up with that demand for the 16 days has also been an issue, but I think SEO has sorted contingency plans for that. So in terms of additional benefits, it just builds on the benefits from the 10-day block, really. So it's even more efficient delivery. As Brian said in that video, I might have some data, I'd have to check actually, but that may become our most efficient job of the year, ironically, despite where it's working. Probably one of the most inhospitable areas in the network for the UK. It's less risk. We've only got a single handback, so less risk to unplanned disruption to passengers. And ultimately for GWR, because we're actually going from a Wednesday to a Wednesday, it only actually affects 2 weekends. So for GWR's perspective and their revenue and protecting their business, it's the best option for them. So I have got some numbers here. It's not very well labelled, but we've tried to take into something we're trying to do in track a bit better is be aware of Schedule 4 costs, overall industry costs. Schedule 4 isn't in our budget. So when we prepare an authority paper to the region, it doesn't include Schedule 4. We only report on construction costs, which is slightly unfair, I think, because we get challenged on the rates we're forecasting to output, but it doesn't factor in Schedule 4. It may be that there's other works in the possession that make us inefficient, but ultimately the overall benefit to the business is greater because it's less Schedule 4. It may be that we're in inefficient access. So working in the Thames Valley, for instance, where we only get a third line for 6 hours, 8 hours, probably limits our output a lot and therefore our costs. So we've tried to be more aware of this. So in this assessment, I've tried to include Schedule 4. So we would have required 11 weekends to do the entire tunnel on the down main. These are construction costs total for 50-hour weekends, all in the same year, which is unlikely, but about 19 million. 2 10-day blocks, we've previously doing it. That saves roughly 2 million in terms of both Schedule 4 and construction costs. And then the proposed 16-day block, we've got much less Schedule 4 again, and we get down to 15 million. So 3 or 4 million saved there potentially, and I think that savings been agreed by the RRR, so I think we're allowed to say that. Thanks for your next slide, please. So in terms of future plans, so we've got, as I mentioned, we've got 16 days of track in Year 1, We've got some significant access throughout the control period, really, mainly for drainage in the tunnel. So the 6-foot drain is reaching the end of its serviceable life as well. So there are plans being looked into to rectify that. Obviously, going back to one of the first slides, managing 50 million litres of water a day whilst working on that asset is going to be a significant engineering challenge, and I'm not sure we as Netrail know how to do that yet. We've also got some works at Patchway Tunnel, which, I mean, I could come back another day and talk about that. And we've got more drainage works, really, and then nothing in year 5 due to the Euro. So we're also looking into the resilience of the OLE system under all these blocks as well. Okay, next slide, please. A bit of a photo dump there. So I was sent some photos from one of the chaps on the videos. So I just thought I'd leave them in the presentation. So there's the shafts that I believe we used for aiding. Aiding construction at the outset. You can see the bottom left here, the muck that's generated in the tunnel. Stamping machine going through, finishing off our works. I was trying to work out in my head why the rails were in the other road. I know we did it in stages, but we did the tamping all at the end, so I'm not sure why there's rails in that road. So don't know the answer to that. Sorry, I think that's one of the new 094S tampers as well, if anyone's interested. And then some other photos, one of the portal signs and the new road renewed and the old road not renewed on the tunnel. I think that's it for me. I saw some comments pop up as I was going through, but yeah, that's it. Thank you. Any questions?
Got a question in the room?
Yes, it's a simple question. Do you have permanent setting out points along the tunnel so you know where you are in 3-dimensional space?
I don't think so.
Oh.
I'd have to take phone a friend for that. You'd like to think so with the OLE, but I don't.
Well, with everything really.
Sidewall, isn't it? I think which shows changes you're on, but I don't know whether they're like coordinates. But they used to be spigots all the way through the tunnel.
Yeah. I'd like to think there is. Like I remember an issue with control when we did the initial survey, but I can't. It was quite a few years ago now, so I don't. I'd like to say yes, but I can't unequivocally say yes.
Now, let us all know.
Yes, no, I'll find out. I'll ask the surveying team. But,
yeah. Is there any risk that with the way that you work, you obviously do the one track at a time? What's the risk to the adjacent track moving because you're excavating pretty close to the track support zone? Because I guess you're excavating from probably where the shoulder is. Is there any temporary works to retain, or have you just got constant automatic monitoring running on the other track?
No, I don't believe we put any additional monitoring in place. There's risk assessments undertaken. I think, to be honest, the way that the drain is shaped, it acts as ballast retention for that side. We've never had any issues, and the shape of the structure, the ballast is quite thick towards the drainage, but on this side, it's actually quite shallow. So, yeah, I don't think we've ever had any issues with
settlement or anything on the other side.
No, I think the drain acts as pretty much ballast retention. Yeah, the barrel bit of it for the most part, but then there's obviously gaps in the catch bits, but it's so minimal by that point that it wouldn't be enough to move it over.
Okay.
So I think
the online question.
Yeah, so as 3 people so far have got online questions, so got quite good attendance. So the first one was from Tom Bateman. So if Tom can come off mute and ask the question himself, that'd be great.
Yeah, hi everyone, and thanks for the presentation. I think Gary has actually answered my question. It was more from selfishly from an OLE point of view. I was just curious if the tolerances and construction tolerances you had vertically and horizontally were less in this instance. My assumption was that the soffit height and profile of the bridge was quite small, but based on the clearances that Gary sent through, it seems like it's probably a bit higher than I thought. So yeah, that was all it was.
Yes, sorry, we lost you for a second there, halfway through the question, but I think the question was, are the tolerances less here than other places? Yes, simple answer.
Yeah.
I don't know what Gary said. Sorry.
The tunnel is quite generous.
Yeah, no, there's certainly worse tunnels to work in terms of clearance, but it's not due to the infrastructure put on the side and sometimes in the top corner where the worst cases were gauged. It would certainly be a significant undertaking to get it clear for W12, but it's not as bad as some tunnels, certainly.
Yeah.
Okay. Yeah, there's a couple. I think Amir has got more of an observation about the dynamic tamping machine. So it seems to be a P&T 09 4x4-4S. So
Yes.
Okay.
That's not what I said.
I don't know.
Not quite. 09 4Ss. That's just what we call them. They're the new ones. They've got DTS capability. Obviously, we're DTSing in there, but they're just run-of-the-mill tamping. They're a lot quicker. So yes, that's what I meant. The full title.
Okay. Dan McCarville has got a query about the tunnel features. Dan, do you want to come off mute and ask your question?
Yeah, thanks, Simon. Yeah, thanks for the presentation. Yeah, I couldn't help but notice on the maps you were showing at the start of the presentation. My question is there any reason why the tunnel features a curve on the Welsh side as opposed to being constructed entirely straight?
That's probably beyond my remit. I'm not sure. I can only assume it's to join up with an existing railway, presumably the SWM1.
Yeah, Severn Tunnel Junction is.
Yeah, I think that was built around the same time as the tunnel itself, raising up yesterday.
SW1 was the original route, wasn't it, from London to South Wales? So, yeah, it would join up with that.
Yeah. Yes, I assume it's just to join to previous existing infrastructure. Obviously, if it could have been avoided, I assume they would have done. But sorry, don't have a better answer than that, I'm afraid.
Yeah, it sounds like history. Ready?
Yeah.
It's probably a good point to say there are some really interesting stories about construction of Severn Tunnel on websites and books.
There was, yeah.
There's some really interesting reading if you're into that kind of thing. I actually worked for months down there on weekends and got quite obsessed with it at one point. But
Mr. Painter loves it. I don't know why.
It is a really interesting construction project.
It's a unique place to work, certainly. Yes, yeah. And I don't envy the chaps doing the drainage, to be honest.
No.
And the last one, because Gary keeps replying to, even though he's left the room. Richard P, would you like to come off mute and ask your question for Martin?
Yeah, hi Martin. Was there any significant CO2 savings with planning to do it in a 16-day blockade rather than multiple 50-hour blocks?
Yes, there would have been. Whether I can quantify them is another matter.
Yeah.
Yeah. Yes. Well, mobilisation to site staff apparently is a big one. I was talking to someone about that yesterday. They would have stayed in hotels and stuff. Although most of the workforce is based in South Wales, so maybe not. Engineering trains, we probably would have saved quite a bit on that. In terms of materials, we've used standard materials, so we wouldn't have saved much on that, unfortunately. But yeah, there would have been some, but not huge. I mean, knowing what I know about the carbon footprint of track renewals, the big thing we need to go at is materials. And actually, we're trialling a site in week 12 this year that's going to have what I call green rail. It's not green, it's the same colour as normal rail, but it's arc furnace produced, which is 60 to 70% lower CO2. We're going to try and use blended ballast, which is recycled ballast and new, to make up certain levels it needs to hit. And also sulfur concrete sleepers. I don't know whether anyone's seen anything about that online. I did find a video that's quite good. It's only about 2 or 3 minutes, but effectively, if you heat that concrete material back up to about 140 degrees, becomes molten again, you can remake the sleeper. So you can. I don't think there's any degradation in doing that process. You can continuously reuse this sleeper using sulfur concrete. So yeah, we are trying to reduce our carbon footprint significantly on a trial site in in week 12 this year.
That sounds like a good presentation to come and do in about week 14.
Yeah.
Yeah, okay, we've got my details now. So. Yes, no, we can certainly do that.
Thanks, Martin.
No worries, Rich. And hello. Yeah, no, we're trying to do the site access as green as possible as well. So diesel free, solar, wind, everything. I saw Mr. Matthews on the online section, so he's a key architect of that as well.
I had a question actually about that in terms of the plant and equipment that's used in the tunnel. Is there a shift towards more electric equipment, so hand tools and things?
Yes.
Maybe not the road railers, but any other gear that you're sort of...
Not road railers at this point,
No.
but certainly Nick's on the call. But yeah, with the technologies there, we're trying to use it as much as possible. Unfortunately, with everything sustainable, there's a slight cost difference, and everyone's just so harsh on the cost these days. It's taking a while to bring it in as business as usual. Personally, I think going to electric RRVs, I think electric everything is just sort of plaster. We need to look at sustainable fuels and hydrogen fuel cell things for long term.
Yeah.
So the amount of R&D that we're required for electric RRVs is probably not worth investing in the long term, in my opinion. But I'm not the person that makes decisions like that. But yeah, in terms of hand tools, battery power, that's all readily available. We are using where possible, but it's getting over the extra cost issue. Unfortunately, we're regulated on overall initial capex, unfortunately, which doesn't align to sustainable output sometimes.
I guess the biggest cost saving would be to do it less often.
Yeah.
So is there any, and Nick might know of something, is there any R&D or innovation pushing for maybe different types of fastenings that may not need replacing quite as often, or any new coatings for rails that would mean you don't have to relay it every 5 years?
So Nick, come in if you're there and you want to. Coatings for rails I'm not aware of. I think there's an aspiration that we'll get to the point where the rail from site is actually reused to make new rail, and we won't have to make new rail at any point, but we're a long way from that. Housings, not sure, but we've got pads and nylons and everything that are getting to the point where they can be recycled and reused. Undersleeper pads, I think, is the big one for me, that someone sent something over to me yesterday that showed Wales and Western were using the least in the country. And the benefits are pretty big in terms of doing it less often, as you say, but we're funded in 5-year periods. We're challenged and regulated on initial costs, and it's not driving the right behaviours to make the changes in terms of whole life costs, and actually investing a little bit more in the output, but you get another 5-10 years out of that asset. With the whole life cost of the asset is much greater, but all we get challenged on is overall costs, initial costs. So it's doesn't really, the objectives and the incentives don't line up.
Yeah, thanks.
Other than the obvious space constraints, has it ever been looked at to do 2 roads together going through the tunnel rather than doing the up and then the down separate?
Not really, no. We use the other road for engineering haulage. Yeah. So yeah, if we're effectively then into a single line territory, which is doing everything in line, which is very inefficient. Yeah. So we might save money, but
you work like opposite directions or something like that. You'd come to a point.
They'd conflict at some point. You need engineering trained paths to get them in and out. So it's probably not. Like I said, it could be done. The only problem is you need lots more access, and the schedule 4 costs are circa 200k a day.
So yeah, you'd work out to a bit where it'd be more expensive to do.
Overall industry cost, it would be more expensive. Yeah.
You said that in your 16-day blockade that you're planning, you've got an issue basically with stockpiling your materials.
Yeah.
Is there going to be an issue with stockpiling the ballast that you're taking out?
Well, yes, no, absolutely. So there's Westbury again has a capacity for spoil, the same as it has ballast, and that needs to be removed before we bring more off site. But I think it's the same answer as the ballast. They'll plan moves to get it off site or They've got West Somerset Railway quite close to Westbury that they use sometimes. So yeah, there's we haven't been told it's an issue in that respect. But you're right, there is a capacity limit to Westbury in terms of spoil as well. If we bring it down too quickly, they might not be able to unload it, and then we don't get the next train and we're in trouble. But yeah, not been told of any issues at the moment.
Hello, good presentation. I'm a signalling engineer, so this is what the question I'm asking really is, through ignorance, I suppose. But you've touched on, renewing of materials like ballast and sleepers and rails, but at the moment, what happens to all the spent ballast, rails and sleepers?
So that at the moment, it all goes back to SCO, so supply chain operations, part of route services, which is in Network Rail, and they will dispose of it responsibly. So avoiding landfill, the scrap rail gets repurposed. The sleepers, I believe, if they can't be used somewhere else, whether they do this enough, I would question, but I'm not sure. If not, it just gets crushed up and it's used as aggregate in other industries. The reinforcement bar gets taken out and scrapped as well. The spoil again is sieved and repurposed and just sold to other industries really. So I think they've got a 96% avoidance of landfill with all the sort of waste materials we give them. So they're repurposed, recycled where possible, and the rest is.
We had a presentation from Westbury, 18 months, was it a Whitemore?
Recycling.
Yeah, okay, and that was about 18 months ago, wasn't it? So
Rails, is it? It was rail.
I thought that was ballast as well, wasn't it?
So Whitemore is sort of where they stockpile reusable materials, and that's the bit I don't think it all lines up yet. Oh, no, sorry, something I didn't say. Before I put the picture of the scrap panels on it, we actually managed to, rather than giving those panels to SCO to do what I've just mentioned, we sold those to
Heritage.
No, to another project that Charlie Berry was doing in Wales. So he's doing a sidings project somewhere. So he's actually used those. We repurposed those back into the railway effectively. So from a sustainability aspect, it was really good. And it was, as you would expect in NetRail, very difficult to get sign off to do that rather than just doing what we always did. I think Michelle Hanforth at the time had to sign off us not giving it back to SCO. So usual NetRail processes trying to get in the way of doing the right thing, but we got there in the end. So thank you.
Okay, I don't think we've got any more. So thanks again, Martin. Yeah, great turnout in Swindon again, and thanks to everyone online. I think we're up to about 30 online today. So
39.
Well, that's good. Yeah, brilliant. So thanks, and hopefully 4 weeks' time we'll be back with a speaker of some description. We'll let you know who that is. I've gone into this parallel.
Yes.